All right, guys. Hope you're doing. Welcome back. I've got a pretty quick video for you today. Just 2 slides talking about some new equations we're going to deal with today. Obviously, yesterday's video and then today's class period was dedicated towards talking about percent mass and percent volume, and how that works in with grams of solute over grams of solution times 100, and then volume of solute divided by volume of solution times 100, and how that worked. But we're going to continue on talking about all the different ways we can calculate and talk about concentration, starting with this one here, which is called molarity, which is like the most common way of expressing a concentration of really any solution. And it's one you guys have seen in lab before, and actually I'll go grab one of the bottles here that's still out in lab. Okay, this little guy right here, okay? This is your HCl, right? It's the HCl you guys have worked with a bunch here, right? And the label of it is it's backwards on my end here, but the label of it is 3.0 big M HCl, right? And the formula is HCl. So 3.0 molarity, which is big M HCl. And so we're able to identify the concentration of these different solutions based on their molarity. And that's exactly what we're going to focus on today, the molarity. Now, molarity is broken down into essentially 2 pieces, moles of solute and the liters of the solution. And so you're actually able to take those 2 things, the moles of solute and the liters of solution, and create this very basic formula for molarity, which has molarity set equal to the moles of the solute divided by the liters of solution. And then you get this really nice and easy to use formula for molarity, okay? The units for molarity are pretty basic, they're pretty simple. The most common one that is used is this big M here, right? So although we have this right here, which is moles divided by liters, which comes directly from the equation, moles divided by some amount of liters here, big M is the most commonly used unit, right? It's the one you just saw on that bottle that I showed you guys a second ago, right? So big M is definitely the most commonly used way to describe the unit for molarity, whereas moles divided by liters is also used, but again, big M or capital M is used way more often than moles divided by liters, okay? So I would prefer to see you guys utilize capital M over moles divided by liters, but if I see moles divided by liters or moles per liter on a test or a quiz, not gonna be the end of the world. I'll still take it for credit, obviously, because they're both correct. But capital M is way more commonly used, so I would try to use capital M more often than that. The second equation we're going to talk about today is called a dilution equation, and it's an important one. It's one that chemists use all the time to make solutions, and so it's one I use actually all the time, right? So in order to make that 3.0 molarity, right, 3.0 molar solution of HCl that you guys have used several times in lab, in order for me for you guys to use that, I make that solution every single day, right? So every single time you guys use any of the solutions in this class, I make them, and I make them utilizing this dilution equation here. And so it's utilizing something called a stock solution, which is generally going to be a solution of a higher concentration. And I'm able to take that solution of higher concentration, dilute it to a lower concentration, but increase the volume of it that I have. And we use this equation here, which is the MAVA equals MBVB equation. And it's basically 2 different measurements. It's a measurement of molarity, which is what we just learned about here, molarity or big M, capital M, and a measurement of volume, right, which is capital V for volume. So capital M is molarity, capital V is for volume. And now we've got MA versus MB, and then VA versus VB. So it's essentially going to be broken down like this. We've got 2 different solutions, solution A and solution B. So MA is going to be represented by the molarity of solution A, whereas VA is going to be represented by the volume of solution A. Now, the other side of the equation is going to be talking about MB and VB, which MB is the molarity of solution B, and then VB, you guessed it, is the volume of solution B. Okay, so you'll have to be able to read through the word problems, specifically when it comes to these dilution equations, to help you decipher and figure out which one is considered the molar, the solution A, and which one's considered to be the solution B, and then kind of use that to help you go from there. Okay. But that's all I've got for you guys today. It's like I said, a very quick video. I'll see you guys in class tomorrow.